So we're going to look at equations of lines, and we're going to take a look at what slope-intercept form is. So in the upper right-hand side of your note sheet, you're going to see y equals. So you're going to write y equals mx plus b.
This was my favorite.
I remember this.
You remember this now? So we already know, what does the variable m stand for? Yeah, so we already know that the variable m stands for slope. Then the variable b is going to stand for the y-intercept. Now, another way to remember it, any number that is being multiplied by x is going to be my slope. So the number being multiplied by x is going to be my slope. If the number is by itself, that's going to be my y-intercept. Now, when I say y-intercept, what does that mean?
You have to solve.
No?
Anything on the y line.
Yeah, it'll be on the y line. Good, Hannah. Okay. So what I would do on my paper, I wouldn't just write y equals mx plus b, because if you're like, Miss Lydican, I don't know what b stands for, I may be like, oh, so sorry, you should have written it on your notes. So make sure on your notes you write y equals mx plus b. You identify what the m stands for, and you identify what the b stands for. Okay, moving along. So we just talked about that. All right, example number 1. We're going to get right into these examples. So your first example says find the slope and the y-intercept. So we're first going to identify the slope, then we're going to identify the y-intercept, and then we're going to graph. I need to change my pen colors for the bright colors here. Red. Do green. My line, yellow. Sorry, guys. Give me just a sec. Okay, so y equals mx plus b. What is the number being multiplied by x?
3.
3. So that 3 represents my what?
M.
Which is my slope. Now my slope is rise over run. So if I just have a 3 that's by itself, how do I give it a run? What can I put up under a whole number to give it a fraction?
Oh, 1.
Yeah, so my slope is going to be 3 over 1. Now my b stands for my y-intercept. So what's the number that's by itself, that's not being multiplied by x? So what's my y-intercept up here? -5, good. So it's -5. So we've identified our slope, we've identified our y-intercept. So I'm going to come over and look at my graph. My line that runs vertical is my y-axis, and my line that runs horizontal is my x-axis. The first thing that you guys are going to find in order to find the slope is your y-intercept. So we're going to start at the origin, and with it being the y-intercept, it means this first point that we're going to graph has to be on the y-axis. So if I start at the origin and I'm going to graph -5, does that mean I'm going to go up or down? Down. So I'm going to go down 5 spots and plot my first point. And it's right on the tip of that arrow. There. Your grid lines might be a little bit different than mine. I'm not real sure. So then from this point, we can now graph the slope. What's my slope? Rise over run. So if I'm going to graph my slope rise over 1, what am I going to do first?
You just keep going until you get to the end.
Well, I'm going to go what?
Up 3 over 1.
Up 3 over 1. So up 3 over 1. That's where I'm going to plot my second spot. Now, you guys all know at this point, I'm real picky about how I like things. Do not freehand your line. You can use your ID, you can use a ruler, but I want to see nice straight lines. I'll get your ruler, Chance. You're going to use your ID? Okay, when you graph a line, it needs to be through both points and to the edge of each coordinate plane. Meaning, I don't want to see a line like this, okay? That's an itty-bitty line. I want that line to go all the way through both points to the edge of each coordinate plane. Now, this is not a line segment. So how do I finish graphing my line? After I make sure it goes through both points and I make sure it goes to the end of the coordinate plane, what does my line have to have? Yeah, arrows. And that's it.
So, okay, yeah.
So looking at this slope, we should be able to tell in two different ways what type of slope is it. What type of slope is it? Positive. So looking at the visual line, we know because the direction it's running, it's positive. Or if we just look at m equals over here, 3/1, we know it's positive because there's no negative. Yes?
Can I keep it going? Keep going up 3/1, up 3/1.
Yeah, so Maddie asked, what if I want to just keep my lines going? Can I go up 3/1? Yeah, so watch. Up 3/, whoops, sorry, I have the wrong thing on. Up 3/1, up 3/1, and you could keep doing that forever, okay? So the slope of a line is going to be the same all the way through. It's not necessary. The thing that I'm going to look for on your quiz are 2 points. I'm going to look to see that you have made a point on your y-axis, so your y-intercept, and I'm going to see to make sure that you did a point for your original slope. Okay? Questions on example 1. All right, example number 2. Okay, so we have y equals 2/3 x plus 3. What is my slope going to be? 2/3. How did you know that was a slope?
Because it's y equals m, that's in the m spot.
Okay, so y equals m, that was an m spot. How do you know that was an m spot? What gave it away? What's the thing that gives the m spot away? It has a what with it? An x, yeah. And then what's my y-intercept? 3. Those are hard to read, aren't they? I need to get some better colors here. So when I go to graph, what do I graph first? Yeah, the y-intercept. So I start at my origin. Do I go up or down? Up 3, 1, 2, 3. And then my slope is going to be what?
Up 2/3.
And then I'm going to make a nice straight line that goes through both points to the end of each coordinate plane here with an arrow. Good. Yes?
Another thing that how I learned, or what Mr. Rickert said, but like he said, we can just keep going up, but we can also keep going down.
If we go down, what are you going to have to do to go down?
Down to
Yeah.
Okay, which way? So, and he's exactly right. So if you're going to go down, you're going to have to go down 2, and then what?
Over 3.
Over 3, the opposite way, right?
Yeah.
Oops, I keep doing
That's what makes sense.
So when you go down 2 and over 3, you're basically changing your slope to -2 over -3. Okay? Which is fine. It's fine to do because then if you go left to right, because if you count, because right there you went from left to right, which when we graph, we always want to go right to left. But sometimes if you have to go left, left, you're going to go negatives, double negatives. Which is fine. You're fine. You're fine. Okay. Example number 3. Okay. What is my y-intercept?
-5/7.
My y-intercept.
Oh, 7.
-7. How'd you know that was the y-intercept? It's in the back, or it's the number that is
By itself.
by itself. What's my slope?
-5/7.
Okay. So what do I graph first?
-7.
So I go to my origin, up or down?
Down.
1, 2, 3, 4. And then my slope from there,
-5/7.
-5/7. So we have a problem, right? If I go to graph -5/7, I'm going to go off the graph, right? Correct? So what I can do for the sake of graphing to keep it on the grid line, you would never write an answer like this, but what could you do with that negative?
Positive.
And then make the bottom a
Negative.
negative. So we're just going to we're going to manipulate that negative so we can graph it on our paper. So when I go to graph, because I move the negative to the bottom, I'm going to go up or down 5.
Up.
So 1, 2, 3, 4, 5. Now, if I'm going to graph a -7, which way would I graph my run then?
Right.
That's if it's positive. because because I'm changing this so I can graph my line on the graph, I'm not going to go right, but I'm going to go left. How many spots?
7.
Okay. So if we're looking here, I now have my 2 lattice points, right? So I'm going to go back up and look at my original. If I find my slope from my first lattice point to my second lattice point, I am going to be able to 1, 2, 3, 4, 5. Whoops, excuse me. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. So that makes this statement true, okay? But because I didn't want to go off road in here, I didn't want to go off the grid, I had to manipulate my negative to get my line on there. Now it still shows a negative. We still have the negative on the right. How I'd want to see your slope written would be the first, but then like I said, you'll have to manipulate it to get the line on. So anytime that you're going to graph off the grid, you're going to have to manipulate that line. Okay, next one. Y equals x minus 1. What is my slope here?
Maybe 1x minus 1.
Okay, so you said because there's a variable that's by itself, I'm going to put a 1. Okay, so what would my slope be?
It'd be 1 over 1.
There you go, nice job. So when the variable is by itself, we know that a variable represents, or it's a standing place for the number 1. So we'd go ahead and put a 1 in there. And then to put it in slope form, we'd make it 1 over 1. And then what's my y-intercept? Negative 1. So I go to my origin. What do I do?
Down 1.
Okay, so I plot my first point there for my y-intercept. And then for my slope,
Up 1 and right 1.
well, that's a tiny line. And if you're like Maddie and you want to keep going, you can put those points and plot them all the way up. Graph your line. And that's it. How do you guys feel about this one? Pretty good. So, lesson 1, lesson 2, and the lesson that we're going to do on Monday, lesson 3, they're all going to be building blocks for systems of equations, which will start on Tuesday. All right, example number 5. Ooh, what is this? How do I fix this one? With the information I'm given, what do I know?
Slope.
Okay, what's my slope?
4, 3.
Okay.
Can you
So-
either put a 1 or keep it 4 over 3?
So my slope is done, but what am I missing?
I'll do those tomorrow.
Yeah, no, whenever is not a rush.
It takes a while to get heated up.
Do I have a number that's by itself?
I'll put it in 0.
Yeah, so there's nothing there. My y-intercept is 0. So if my y-intercept is 0, where do I graph my y-intercept on the line?
On the 0.
On the 0, my origin, right? So I leave that there. And then I'm still able to find my slope, which is rise over run. So that, what does that mean I do?
Up 4.
2, 3, 4.
Right.
Fabulous. You guys are nailing it. Makes me happy. How are we doing back there, Riley? All right, flip them over. Are we ready to flip over? We already flip over? We already flipped over. Chance is slacking. You heard me.
Yep.
Ooh. I gave you guys another fun one.
Oh, this one's easy.
Tell me how it's easy. Explain it to me.
So, you go over 1 on your y,
Okay, why am I doing number 1 on my y?
because, it's 0, basically.
You're saying all these numbers, I don't know what they mean.
Is that right? What do you just draw on the y-axis?
This,
Okay? So explain to me what you did now.
I drew a line on 1.
Okay, so you know that the 1, because it's by itself, it represents what?
1.
The slope or the y-intercept?
Slope and the y-intercept.
The y-intercept. Because the number is by itself and there's no variable x with it, I know that that number by itself is going to be my y-intercept. But what am I missing here?
Your
Your
X.
slope.
I'm missing my slope because there's no variable there, right? So if I have no slope there, what's it going to be?
0.
Over 1. So when I go to graph this, as Chan said, I grab my y-intercept first, so I start my origin, I go up 1. Well, my rise is 0, but my run is what? 1. So I know that this slope is going to have a slope of 0. So it's basically going to be, what kind of line is this?
Zero fun.
A 0 slope line, but what is it going to be called? What'd you say?
Undefined.
Zero fun.
0, yeah, has a slope of 0. Now, undefined is not a horizontal. There you go. It's a vertical. Don't worry, we'll see one of those two. We got it? Okay, example number 7. Ooh,
6/1 minus 8.
but what's wrong with this? I love giving you guys different kinds of problems.
You gotta divide it by 2.
Why?
Because you gotta get 1 by itself.
Nice job. So I'm going to circle my variable. I'm going to draw my line. We're going to run out of room, guys. So I'm going to come over here. Hopefully I have room over here. Where am I going to have room to write this? I'll just try to squeeze it. I'll do my best.
On board.
So I'm going to circle my variable, draw my line. As Chan said, I want to get rid of the 2. And how did you do that?
Divide it.
So if I divide my left side by 2, I'm going to divide my entire right side by 2. Okay? So then I'm going to have y equals,
3x minus 4.
okay, so 3x. That's not going to work. Okay, so 3x minus 4. So I basically have this. So I have an equation that's written in slope-intercept form because now I got it in slope-intercept form. So now I can identify what is my y-intercept.
3.
What's the number by itself?
Oh.
Remember, the y-intercept is
4.
what kind of 4?
Negative
And what's my slope going to be?
3 over 1.
3 over 1. Good. Okay, so I go to my origin. What do I do?
Down 4.
And then what?
Up 0 over 1. Sorry.
3.
You got it. This line's going to be hard for me to draw on here. There we go. What kind of slope is this line going to have? Positive. And last example problem. Eee. Another fun one. But Chance already kind of gave us a skill or the tools that we needed. So we know in order to get it in slope-intercept form, we have to get what by itself? The y. So what do I get rid of?
7.
So I'm going to subtract 7. Now, when I subtract 7, I can only do so by combining like terms. So can I take 2x and subtract 7 from that?
No.
No. So it's going to be y equals 2/3 x. But can I combine positive 4 minus 7? Are they like terms? They're both constants, right?
Where's the negative 7?
So what's positive 4 minus 7? Negative 3. So here's my new equation in slope-intercept form. So y equals 2/3 x minus 3. So what is my y-intercept?
Negative 3.
And my slope?
2 over 3.
Go to graph it.
Down negative 3.
And then for my slope.
Then up 2. Over to the right 3.
Dylan, you killed this lesson. Nice job. Or that was a terrible line on my behalf. Or that was even worse. Nice job. Any questions?